Today I'm going to talk about the who, what, when, why, and how of New York City Water Tunnel number 3. The who. The New York City Department of Environmental Protection is building tunnel number 3 to supplement tunnel number 1 and tunnel number 2, the existing tunnels that were built in the early 90s. They're also going to allow for those tunnels to be inspected and repaired by the Department of Environmental Protection. The latest segment of the tunnel number 3 that is currently being built is the Queens section of Stage 2, and it was awarded to Grove Tunneling Corporation, Perini Corporation, and Skanska joint venture. The tunnel is broken into 4 stages. Stage 1 starts at the Hillview Reservoir. It's 13 miles long, and at the head it's a diameter of 24 feet, and it tapers down to 20 feet. Stage 1 also included the construction of 3 valve chambers, one at Van Cortlandt Park, Central Park, and one at Roosevelt Island as well. Uh, Construction started in 1970 and it was completed in 1998. It cost approximately $1 billion to build, and it was built using the drill and blast method of tunneling. Stage 2 consists of 2 sections. One is the Brooklyn Queens section. It's a 5.5 mile stretch that's 16 feet in diameter, a 5 mile stretch that's 20 feet in diameter. And then there's the Manhattan section that's 8.5 miles at a 10-foot diameter. The Manhattan section was completed in 2010, and the Brooklyn Queens section is scheduled to be completed in 2021. And this tunnel was dug using TBMs, or tunnel boring machines. And complete with stage 1, it'll allow for the existing tunnels number 1 and number 2 to be taken offline, either one at a time, so they can be inspected and or repaired for the first time since they were completed. Stage 3, it's going to be, is proposed, it will be a 16-mile stretch, 24 feet in diameter, from the Skanska Reservoir to Cortlandt Park valve chamber. Tunnel number 3 will be able to have an increased pressure once this is online due to the increased elevation of Skanska Reservoir. This is important for when tunnels 1 or 2 are offline to keep up water pressure to residents. And then stage 4 is also proposed. It's going to be 14 miles long, and it'll run from Van Cortlandt valve chamber to Queens, and it's still in the early planning phases, but it's currently just proposed. So the technology that was used when building these, the TBMs, the tunnel boring machines, they were first used in stage 2. Before this, the previous method of tunneling was the drill and blast method, which basically consisted of drilling a series of holes into the stone, packing it with black powder, dynamite, and blowing the wall, and then clearing it out and repeating the process over and over again. The current method of using TBMs is twice as fast, it's much safer, and it's now the industry standard of how tunnels are dug. And it's was basically pioneered during stage 2 building. And then the concrete delivery. So it was through Maxim, and they basically custom built a set of agitators and Maxcrete remix units to pour these. So what they were dealing with on site was they had a 25 to 35-minute drive from their batch plant. And then there's a lot of segregation that occurred because they had to drop the concrete down a 750-foot shaft to get to the actual depth of the tunnel. And then when they were pouring the tunnel, there's also the distance they had to cover within the tunnel. So at max, they had a 55-minute travel by rail once they were down in the tunnel. So Maxim's solution was 12 open agitators versus like traditional drum agitators, which you would see on concrete trucks. And this allowed the agitators to be loaded extremely quickly, transferring 13 yards of concrete in 2 minutes. So it was extremely quick compared to traditional methods of transferring concrete. And with the agitators and the Maxcrete remix machines, they were able to pour 24 days or 24 hours a day, 5 days a week, and it was basically nonstop during the week. And max, when they were closer to the tunnel, they were pouring up to 5,000 cubic yards a week, which is an insane amount of concrete to think about. And overall, this method was just faster. It was more reliable. The open agitators were easier to work on if they did break down. And it was just a very successful system in building this tunnel. And it's some technology that it wouldn't have been built otherwise unless this tunnel was built. Here are my citations. Thanks for watching, guys. Leave any questions or comments below.